So this is another section. This is a L section. So we have to find out the center of gravity of this section. So first we have to check whether it is symmetrical about x-axis or y-axis. You can see if we'll cut it by x-axis, it is not symmetrical. Similarly, if we'll cut it by y-axis, then also it is not symmetrical. So in this case, we don't know where the center of gravity will lie. So we have to find out both the x coordinate and y coordinate. So we have to find out the x coordinate. It is a combination of two sections. We can divide it like this. We can divide it like this. This is a section 1. This is the section 2. So in this case, x bar the formula for x bar equal to a1 x1 plus a2 x2 divided by a1 plus a2. So this is first section. So you have to find out a1 equal to this total side we have taken, this is one section, so the total is 80. So up to this it is 80 minus 20, that is 60 mm into 20 mm area of the first section. Similarly, we have to find out x1, the x coordinate of the center of gravity from a reference plane. So I will take this side as a reference. So as it is a rectangle, its center of gravity will lie at its middle, that is this portion is 60, that is 60 by 2 equal to 30 mm. But I have taken this side as a reference. So 30 plus 20, x1 equal to 50 mm. Similarly, we have to find out A2, area of the second section, that is 100 into 20. 100 into 20 mm square. Similarly, we have to find out x2. x2 equal to center of gravity of this section from a reference, x coordinate of center of gravity, that is 20 by 2 equal to 10 mm. So we'll put these values in the formula. X bar equal to a1 60 into 20 into x1 is 50 plus a2 into x2, a2 is 100 into 20 into x2 is 10 divided by a1 plus a2, that is 60 into 20 plus 100 into 20. Similarly, we have to find out y coordinate also, as it is an unsymmetric section. So a1 y1 equal to a1 y1 plus a2 y2 divided by a1 plus a2. So a1 equal to, you know already, 60 into 20 mm square. y1 equal to y coordinate of center of gravity of this geometry. I have taken this surface as a reference. So y bar equal to, for this geometry, y bar equal to 20 by 2, that is 10 mm. Similarly, a2 you already know, 100 into 20 mm square, 120 mm square. y2 equal to y coordinate of center of gravity of this section from this reference. This reference is common for this one, this section and this section. I have divided it like that. So for this section, the y coordinate will lie at its middle. So 100 by 2, that is equal to 50 mm. So we will put it in the formula. So y bar equal to 60 into 20 into 10 plus 100 into 20 into 50 divided by a1 plus a2, that is 60 into 20 plus a2 is 100 into 20. So we will calculate both x bar and y bar and we will find out the location of center of gravity from its reference. We can also divide the section like this. Like we can also divide this portion. I will draw it again. This side is 100 mm, this is 20 mm, and this total is 80 mm, this is 20 mm. So we can, earlier we have divided it like this. This is section 1, this is section 2. We can divide it like this also. Like this part is section 1 and this part is section 2. So in this case, A1 equal to 80 into 20 mm square. Y1 equal to, in this case y1, we will take this surface as a reference. So y1 is 20 by 2, that is 10 mm. Similarly, A2 equal to, this total is 100, so 100 minus 20, that is 80. 80 into 20 mm square. Similarly, y2 equal to, this is 80, so 80 by 2, this portion is section 2, so it's up to this, it is 80 mm. So y coordinate of center of gravity will lie at its middle, that is at 40 mm. But we have taken this surface as a reference, so 40 plus 20, that is 60 mm. Similarly, we will check the x coordinate. So x1 equal to, for this section, x1 equal to 80 by 2. We have taken this surface as a reference. So x1 equal to 80 by 2, that is 40 mm. Similarly, x2 equal to, this side is 20. We have taken this surface as a reference. So 20 by 2, that is 10 mm. So we'll put these values in the formula, above mentioned formula for x bar and for y bar, and we'll find out the answer. Both the answer will be same.